just the merge sort. How to do the merge sort. Here, the problem size n equals 12. How about, in my example, I try n equals 10. So I run this n equals 10 from beginning to end, step by step, and get the worst case, the number of comparisons. So after that, I think you can easily solve this question in a similar way. All right, so let's start. Let me draw one line segment representing this array. And let me write these 10 elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. All right. So that's all the elements here. Now, when we split the element, we try to split as even as possible. So we follow that. When we get one element array, we stop. So use this guideline, then we do the divide and conquer, and merge to combine two of the adjacent subarrays. So let's do it. First, we split two subarrays in this one. So each one 5 elements, even. Next, 5 elements, we cannot do even split as even as possible. Here, let us do first one 3 elements, second one 2 elements. Okay, so let's use this way consistently. Next one, the first one, still also 3 elements, next one 2 elements. Then next split, all right, 3, so the first one 2 elements, the next one 1 element. So this one 1 element, and we can stop, right? Yeah. So 1 element subarray. Here, all right, split. Here, split. All right. So the last round, this split. Okay. This split. All right. Okay. Yeah. Now we do the merge. We do the merge round by round in the inverse order of our split way. Reverse order. Okay. Each round we count the number of comparisons for the worst case. Then we add them up. We get a final answer. All right. First round merge to the adjacent array. These two, 1 comparison, right? Worst case. Total number of elements minus 1. Remember the formula we use for the worst case. The first array m element, second array n element. Total number of elements minus 1. That's the formula for the worst case. Worst case merge. So we use this formula repeatedly. Okay? Alright. So we merge these 2 subarrays, 1 comparison. Then reverse order, these 2 should be the next one, right? Yeah. So also 1. Also 1. Okay? Yeah. So here we want to do the way in the reverse order. Yeah. Because our last 2 split here. Yeah, last 2 splits here. Reverse order. Yeah. Recover to the previous subarray. Yeah. Because after this merge, these 2 mergers, we get the previous split state. Previous state, right? Yeah. We recover to the previous state. Here we just want to get a consistent rate. Although some people may not use this way, slightly different. It's okay if you set the rules and you use your rules consistently. That's okay. Your answer, if your answer is slightly different, I hope the difference is just one at the most. That should be fine. That should be fine. Yeah. Anyway, all right, so that's the first round. So you can see this round, the total number of comparisons, 2. Okay, 2. Number of comparisons. Okay, so let me write here, number of comparisons. All right, so that round. Then previous round. So we covered previous round split. The previous round, we should do this merge, right? Total elements 3 minus 1, 2. So for the worst case, 2 comparisons. These two, 1 comparison, right? 4, 5, total number of elements minus 1 to 1. And here, what's that? Right here, we should have this, that previous subarray. So 2 and 1, right? So this one merge. Let us look at total number of comparisons. 2, 1, 2, 1, 6, right? 6. 2, 1, 2, 1, 6. Then we recover to the previous one. Exactly the previous state. So in this way, so we try to make the whole procedure organized in a natural way. Natural way. Yeah. All right. So the previous round now merge these two adjacent subarray. 3 elements, 2 elements, total elements 5. 5 minus 1, right? So 4. 4 elements. Yeah, we keep using this worst case formula. So 4 comparisons. Here also, total number of elements 5. 5 minus 1, 4. So this round, our total number of comparisons, 8. 4 plus 4, 8. Then, final round merge. The last 2 subarray merge, total number of elements 10, 10 minus 1, 9. 9 comparison for the worst case. So the last round, 9. Now you add it up, these 4 numbers added up, 10, 15, 25, right? So the answer is 25. So for this example with 10 elements, in this way, the total number of comparisons for the worst case, 25. So you just use the same way, but you use n equals 12. So when you do split round by round carefully, then when you merge, just reverse your split procedure in a reverse way. Carefully count number of comparisons for each merge. For the worst case, using this formula, worst case formula, carefully, then finally add up all the comparisons for all rounds. All right, that's the first question. The second question. All right. Now, this one related to the insertion step, but I want to calculate average case number of comparisons. The question, we have 25 elements. In my example, how about I try n equals 12 elements, right? 12 elements. Okay. Fourth element, how about I do third element, right? Yeah. Greater than third element. Smaller than, how about I set ninth element? in my example. Yeah, let me do this one. So then you can easily work the same way to solve given question. All right, so 12 elements. I can write it out. Okay? Yeah. When you write 25 elements, you do not have to write all of them. Yeah. You just write, some of the important numbers. Yeah. Here, 12, not too big, so I can write all out, right? 2, 3, 4, 5, 6, 7, 8, 9. That's all here, 9. I don't want to miss 9, 10, 11, 12. Now, the condition. The element to be exerted is greater than the third elements by comparisons, right? Yeah, or third, yeah, right? Okay, greater than third element, right? Greater than third. That means these three can be eliminated from the consideration. So we won't touch these three elements. Then smaller than ninth, smaller than ninth, right? So these elements we do not need to touch. Okay? Now, when we count the average, right? Average case comparisons, how many total cases do we have here? Total number of cases, 5 cases. All right, for each case, you need to figure out how many comparisons. When you have this one, okay? So when you insert elements, so here, less than. All right, so the location, here, because when you insert element less than 9, so the location, first location could be here, right? Second location here. Slot, second slot, possible slot, third possible slot, possible slot, possible slot, possible slot, right? 1, 2, 3, 4, 5, 6. Yeah, actually, although we have 5 elements, but we have total 6 slots. How about that? How about that? Slots. 6 slots. All right. For each slot, let's look at number of comparisons. How many comparisons for the first slot? Okay. Compare with the last one, less than last one. Okay. Less than. So 1, 2, 3, 4. Less than, but the fifth one greater than. Okay, greater than 5. So we need a 5 comparison to get a first slot. 5 comparison, greater than. Right? So smaller than this one, but greater than the next one. So 6 comparison. Next one. 7 comparison. 8 comparison. 9 comparison. 10 comparison. Oh, yeah. So that's the number of comparisons for each slot. We only have these 6 cases. Now we need to take the average of these 6 cases. So we just use the standard average definition. So the average equals 5 plus 6 plus 7 plus 8 plus 9 plus 10 divided by 6, right? The first one plus last one, 5 plus 10 divided by 2. Okay? Yeah. Although the total we need to multiply 6 divided by 6, cancellation, so this number. Okay? 15 over 2. That is the answer. So, yeah. So here I use a special example. For our original question, you do it in a similar way, but you need to figure out carefully how many slots do we have. For each slot, how many comparisons you need to do for each slot. Then you take average. All right, so that's the first 2 questions. So let me finish our second video, G.2. Then our last video, G.3, I will explain the remaining 3 questions. All right.